Today we're going to talk about the rock cycle and a soil profile. Let's go ahead and start with the rock cycle. Now remember, it's a cycle, so what we end up with is going to be used to start the process again. But let's just kind of pick a point where we can begin. Let's start with igneous rock. Now we've got hot rock coming up out of the planet. And this hot rock, this lava, spreads down the surface of the earth. When that rock cools, we're going to call it igneous rock. So let's go ahead and start there. Igneous rock. That's what happens when rock, let's call it molten rock. That's what happens when molten rock cools. Igneous rock. Now, eventually this igneous rock is going to get weathered away through a process called erosion. And this igneous rock is going to get eroded into sediments, into smaller pieces called sediments. And those small pieces are going to make up, they're going to build up layer by layer by layer, and they're going to create sedimentary rock. And that sedimentary rock is made up of sediments, small pieces. Now, these small pieces over time, as those layers of sediments accumulate, they're going to get squashed together. And as water with dissolved minerals, water contains dissolved minerals, as that water with dissolved minerals seeps between the sediments, you can think of that water and dissolved minerals as like a glue. And eventually, when that water evaporates, the dissolved minerals are going to glue the sediments together into sedimentary rock. So water and dissolved minerals, that's going to be a glue. And it's going to glue our sediments together into sedimentary rock. Now, eventually that sedimentary rock can get transported deep down into the earth. It can either get buried, or maybe through a process called subduction, it can get dragged down deep into the earth. Either way, it's going to get exposed to a lot of heat and pressure. And that heat and pressure is literally going to break the atoms of the sedimentary rock apart. And then those atoms are going to recombine in new ways to produce a new type of rock called metamorphic rock. And that's what metamorphic means. It means to change. So this is going to be metamorphic rock. It is changed rock with different chemical and physical properties than what we started with. Now, even that metamorphic rock can, if it further heats up, can turn into igneous rock. Molten rock, which eventually maybe makes its way to the surface and cools again. Now, all these different rock types here are interconvertible. So our igneous rock can actually turn into metamorphic rock through heat and pressure. And our metamorphic rock can turn into sedimentary rock through erosion. And our sedimentary rock can turn into igneous rock if it heats up and melts. So all these rock types are interconvertible. Now, the next thing I want to talk about is what's going to happen when these rocks, and all these rocks at some places on Earth, are exposed to the surface. They're exposed to the atmosphere. What's going to happen to these rocks when they're exposed on the surface? Well, they're going to undergo a process. And this process is going to result in soil formation. And I want to talk about soil formation. And it can take thousands and thousands of years to occur. And I want to talk about soil formation in terms of a soil profile. So let's go ahead and start there. I'm going to go ahead and I'm going to erase my rock cycle. And we're going to start with solid rock. on the surface of the earth. And it doesn't matter if it's sedimentary rock, igneous rock, or metamorphic rock. It's rock. And we're going to start there. So I'm going to draw a nice big square here, big rectangle actually. And that's going to be my parent material. And this parent material, we're going to go ahead and give it a name. We're going to give it an abbreviation called R. The R horizon. Horizon means layer. It's the R horizon. And R stands for regolith. Lith means rock, regolith. Or we can call it bedrock. That's essentially what it is. Solid rock. Bedrock. Now, eventually, what's going to happen is this solid rock, this solid bedrock, is going to get busted up into smaller pieces through the process of weathering. So let's go ahead and show that. So there we are. And this is going to be, let's call it partially weathered parent material. And we're going to call that the C horizon. Now let's just call it parent material. Now, eventually that partially weathered parent material is going to get colonized by living organisms. So let's go ahead and draw another layer on top of here. And this next layer, this partially weathered parent material that gets colonized by living organisms, eventually those living organisms, they obviously grow and they die, and their decomposed remains get mixed in with this busted up material. So this next layer is going to be composed of minerals, which are busted up parent material, even smaller pieces, minerals, and humus. Now humus is decomposed organic remains, decomposed material. That's what humus is. And that's going to be the A horizon. We're actually going to call that the A horizon, or our topsoil, because it's the topmost soil. Now, on top of that, we're going to get living materials growing, living organisms growing, grasses, trees, things like that. So we're going to have an organic layer on top of this. So organic material. Sometimes we call that organic material leaf litter, because oftentimes it's composed of leaves and twigs and branches and things like that. It's that dead material that sits on top of the soil. We've all walked through it in the woods and kind of, just kind of pushed it along with our feet. All those leaves, all those twigs on the ground. Now it's organic material, so we're going to abbreviate that horizon or layer with the letter O for organic material. Now, there we go. There's the top of our organic layer. Now, something else is going to happen here too. Because as it rains, the water is going to percolate down through the various horizons or layers of our soil profile. And as that happens, the A horizon, there's some minerals in there. There's iron, there's going to be aluminum, there's going to be clay, there's going to be other things. But these three materials get washed down or leached down into the bottom of the topsoil. And that's actually going to create three distinct layers. So we started with the A horizon, And because of leaching, because water actually transports iron, aluminum, and clay downward, we're going to end up with 3 layers. So there's our A horizon right there. And then we're going to have 2 more horizons. So where iron, aluminum, and clay get leached down here, it becomes a reddish layer. A reddish layer. And we're going to call this reddish layer, it's red because of the iron, this reddish layer is going to be called the B horizon for our subsoil. And this horizon right here, which is now devoid mostly of iron, aluminum, and clay, it takes on a very grayish appearance because it's lacking the iron especially, a very grayish appearance. And that grayish layer is going to be called the E horizon. And this E stands for eluviation. Eluviation. And eluviation simply means to transport downward. So to transport downward. Now, this is an ideal soil profile. You're not usually going to find every single layer nice and pretty like this. In some areas, you might find a few of these horizons. In other areas, you might find other horizons. It depends on what minerals are present, how much oxygen is present, how much water is present. All kinds of different factors are going to figure into the formation of the soil profile. So if you dig down into the ground, chances are you won't find every single layer nice and pretty like this. You could, but it will be tough in most places. Now let's go a little bit further here, and I want to talk about the A horizon, right there. That's probably the most important horizon of them all, because this is what most life on Earth depends on, the A horizon, the topsoil. In fact, that is the layer where we grow all our crops around the world. Now a funny thing here, maybe not so funny, but that A horizon, that topsoil over the past 100 years, in many, many, many parts of the world, has been eroded away due to poor farming practices, specifically industrialized farming, very intensive farming, where we till up the earth with big tractors, we put fertilizers on the ground, artificial fertilizers, pesticides, we're using a lot of irrigation. So what is happening here is this topsoil is becoming less and less productive, less nutrients in there, and a lot of it is just plain eroded away. It's not there anymore. In fact, in the middle of the United States, the breadbasket where we grow most of our food, we used to have beautifully rich soil there because of all the grasslands. Beautifully rich soil. Well, in the past 100 years, we have lost over half of that soil in many places. Over a half. Now, if you can extend that out a little bit further, because this whole process takes thousands of years, and we've lost over half of that topsoil in 100 years, those numbers don't add up. That's what we call unsustainable. In the next 20 or 30 years, as we lose even more of this soil, we're going to run into major problems. We're going to have difficulty growing our food around the world, not just in the U.S., but around the world. However, there is good news. And the good news is this. We, the consumer, can change this. We, the consumer, have the power via our buying choices to change this system. If we, the consumer, choose to buy good organic foods, foods that are produced in a sustainable way, then that type of farming is going to be encouraged. And if we, the producer, do not purchase industrial produced foods that tend to be cheap and of poor quality, then that type of farming practice is going to be discouraged. Something to think about in the future, because it's us that are going to be facing this problem. And it's us that need to change the problem through changing our buying habits. And that's going to be it for the soil profile.